everybody. Welcome back to my daily tutorials. Today I have quadratic equation where asked I'm going to solve it using graphical method. Remember, in so many clips we explained that quadratic equation can be solved in so many ways, like substitution method, formula method, not substitution actually, formula method, completing the square method, factorization method, and lastly graphical method. So I'm going to use graphical method to solve this problem. That is what? Solve y equals to x squared minus 2x minus 5 graphically. I know there are so many differences in approaches, even the graphical solution have different varieties. The way I'm going to do my own will be different from the way other people will do their own, but I always assume my own is the best. So I want you to stick to me to the end of this video so that you can see full of how equation is solved using different graphical method. But before then, please help me subscribe to the channel, follow, and make sure you touch the notification bell so that anytime I upload a new content, you will be notified. Now, to solve this, let me just write solution from this part. Let's say solution here. Now bring the equation down, which is y equals to x squared minus 2x minus 5. It's simple. The quadratic graph used to have three important points along the graph or on the graph. If the graph looks like this, there are three important points. One is along the negative x, which is here, along the positive x, which is here, then along the negative x, which is negative y, which is here. Depending on the quadratic equation, if it is curved upward, this is where the minimum point will be. If it curved downward, the minimum point should be at the positive, the maximum point of y should be at the positive side. So now I assume the coefficient of x squared here is 1, therefore it must curve upward. That is number one condition. So having this done, we have three important points on the axis. The two along the x-axis, while one is on the y-axis. So I'm going to consider only these two to form my table. In this solution, I don't do that table of like minus 4, minus 3, minus 2, no, up to 1, 2, 3. The points are too much. With 3 points, you can be able to make your graph. Now what we should do is just form a table of 3 columns only, like this. This is your x, this is your y. Maybe you have this and you have this and you also have this. Now this should be my table only. Now you can assume if you start from minus 4 or minus 3, maybe start from minus 3 to 4 or to 5. Like let's say minus 3 along the negative x-axis, then the midpoint where we can have the maximum or the minimum value of the y should be 0, and maybe plus 4 here. Now using these values, we can be able to find the value of y with respect to this equation. So what we should do is to first of all say when x equals to minus 3, what happened to the y? Substitute through x with minus 3 here so that we can know what our y to be. That is minus 3 squared minus 2 bracket minus 3 and minus 5. Now after this we have minus 3 squared is just 9, minus is minus is plus 2 times 3 is 6, then minus 5. This is 6, 9 plus 6 is 15, minus 5, and this is equals to 10. That means here is 10. Now as y equals to 10 when x is minus 3, let's quickly jump into when x is 0. That is when x is 0, what happened to the y? We substitute x with 0, we have y equal to 0 squared minus 2 bracket 0 minus 5, and this is equal to 0 minus 5, and this is minus 5. From this place is minus 5. Simply. You see how simple this method is? Wait till the end. Wait till the end. You see how simple it is. Now from here, we consider x to be equals to 4. When x is 4, what happened to the y? We substitute x with 4. We have y equals to 4 squared minus 2 bracket 4, then minus 5. Then we have 16 here minus 8 minus 5. And this is 8 minus 5. And this is exactly 3. Now x or y is 3 when x is 4. Now immediately after this, we now quickly go into plotting our graph. Like let's draw our axis, but there is something I want you to consider. This is negative x, this is positive x. The highest value here is -3 along this way. The highest value is +4 along that way. Then y has 10 in the positive side, then it has -4 in the negative side. So that means we have -5 in the negative side. So what we should do is to draw our axis to be this way, like we draw our axis to be, the y-axis should be here. The y-axis should be here. Take it down. Take it down and maybe increase it up small. Increase it up small. Now this is our x-axis again. From here we can have our x-axis, that is this towards here. Now we make this to be our origin. Remember, if you take 1 centimeter to represent 1 unit, that is 1. We have 2, we have 3. We increase it. We add it, we increase it. That means we have here will be 4. You stop it there, which is positive x. Here will be -1, -2. We increase this also. Then here will be -3. You have to be accurate because you are not using graph book or graph paper or graph board. That means you have to be very accurate. Distance from here to here should be equal. Even by measurement, it should be equal, approximately equal everywhere. So that's what you have for the x-axis. This is negative x. Then y, because 10 is a big value, so we can use either 2 centimeters to represent 2 units, that is 4. 1 centimeter to represent 2 units, 4, 6, 8, then 10. You can make it 12. This is positive y. Now this is 2, this is 4, this is 6, this is 8, this is 10, and make it 12. From here 1 centimeter also, -2, remember, -4, then we have -6. This is -1. These are the axes we have approximately. So from here, what we need to have now is to plot our point, meaning when x is -3, y is 10. X is -3 here, this is -3, y is 10, is up, like we should use which arrow to know. But you have to increase your accuracy here. I think they made around here. They made the coincidence point is here. Now the two of them coincide here, so that's what we have at the first point. Then when x is 0, y is -5. -5, here the center here is going to be -5. This is the center. So because here is -4, -5, -6, so this is where -5 is going to be. So from here we have x is 4, y is 3. X is 4, y is 3. Our 3 should be the center here. That is the 3. Now, if assuming our 4 goes here, then our 3 comes here. Our 3 comes from there. So I think it's going to be somewhere around here. So that is our respective point. So the next thing is to match the 3 point. A curve, a normal curve. So there is little limitation in this method. Now the limitation we have in this method is, it doesn't give exact readings. It doesn't give exact value of the x. Why? Because we are using only 3 points, only 3 points. And let me tell you, 3 points won't be enough. Only 3 points won't be enough for you to detect exactly the roots of a quadratic equation. That's the reasons why they are using -3, -2, -1, you understand me? But that one had the simplest one to do is this one, but only when you are very much accurate in drawing this axis. In drawing this curve, you must be very accurate. You must be extraordinary, extra accurate, so that you can have exactly what you need to have there. So I want you to find the value of x, or let me just proceed and find the value of x. The first value of x lie here, and the second value of x also lie here. So let's start with this. X will be equals to, if from here to here is -1, -2, that means we have -1, 2, 3, 4, 5. So -1.2, -1.4, -1.6, -1.8. So -1.8. That's what we have. Now from here, if here is like we have 1, we have 2, we have 3, we have 4, we have 5. So here will be 3.2, 3.4. That means x equals to this, or x equals to 3.4. So these are the two values of x's. Now, it's not advisable to use this when you want to get exactly your answer, your correct readings. The roots should be very correct, then you cannot use this. But if you want to get approximate readings or approximate root, then you can use this method. You find it very easy, you do it easily, you plot your graph easily and get your readings. But the certainty, or let me say, the probability of having this correct is just small. So that's why. If you use another method to solve this, you find out that the values must never be this. It's something very close to this. It can never be far from this. It's very close. You can use either a factorization method, or you should use formula or completing square method to solve it. Then you find out the differences are very small. So let me just test it using another method.